Which event has a probability of 0? 1. Choosing a letter from the alphabet that has line symmetry. 2. Choosing a pair of parallel lines that have unequal slopes. 3. Choosing a number that is greater than 6 and is even. 4. Choosing a triangle that is both isosceles and right. Let's find out. We're going to solve this one by one, but first of all, we have to know what is the definition of probability of 0. Probability of 0 means that an event that is impossible to happen. Number 1 says that choosing a letter from the alphabet that has line symmetry. Let's say you get the letter W or the letter U, and you decide to put a line through them, just like this. That makes it has a line of symmetry. So that makes number 1 incorrect. Number 2, choosing a pair of parallel lines that have unequal slopes. It is a fact that if lines are parallel, then their slopes are the same. That makes option number 2 correct. We're not going to stop here. We're still going to see number 3 and number 4. Number 3 says choosing a number that is greater than 6 and is even. So let's say we get the number 8 or 10 or 12, and there is more. Letter 8, 10, and 12 are both even and they're greater than 6. That makes number 3 incorrect. Number 4, choosing a triangle that is both isosceles and right. We're going to see over here 45, 45, and then 90. Those are both isosceles and right. So that makes question 4 incorrect.
The faces of a cube are numbered from 1 to 6. What is the probability of not rolling a 5 on a single toss of this cube? So the probability not rolling a 5. When a single die is thrown, there are 6 possible outcomes. We have 1, 2, 3, 4, 5, and 6. Number of ways it can happen 5. So total number of outcomes is 6. Total is 6. So we need a number less than 5. 1 is less than 5, 2 is not 5, 3 is not 5, 4 is not 5, 6 even it's not 5. So the chosen numbers are 1, 2, 3, 4, 5. So 5 over 6 is the final answer. Thank you for watching.
When a fair coin was tossed 10 times, it landed heads up the first 7 times. What's the probability that on the 8th toss the coin will land with tails? Up. 3 over 10, 1 over 2, 7 over 10, 3 over 7. A fair coin has 2 sides, head and tails, that are equally likely to show when the coin is flipped. So the probability that on the 8th toss the coin will land with tails up equal 1 over 2.
The question says, a number is selected at random from the set below. What is the probability that the number is odd? Now the numbers we have are -3, -2, -1, 0, 1, 2, and -3. Since the question asks, what is the probability of the number being odd? So let's exclude all the even numbers. In our case, the even numbers are -2, 0, and 2. We are now left with -3, -1, 1, and -3, which are all odd numbers. So in total, we have 3 even numbers and 4 odd numbers, which equals to 7 numbers in total. And since we have 4 odd numbers, the probability of us choosing a random number and it being odd is 4/7.
Alma and Blanca are playing a game where they roll a pair of fair six-sided dice and try to predict the outcomes. Blanca thinks that the probability of rolling a 1 and a 5 is greater than the probability of rolling a 1 or a 5. Blanca thinks rolling a 1 and a 5 is greater. Alma disagrees. She thinks that the probability of rolling a 1 or a 5 is greater. Alma disagrees. She thinks that the probability of rolling a 1 or a 5 is greater. Based on the sample space, the possible outcomes listed below, who is correct, Alma or Blanca? Here we have 6 by 6 rolling dices, which makes 36 rolling dices. Let's start with Blanca. The probability of Blanca is rolling 1 and 5 equals, as you can see here, 1 and 5. There's 1 and 5, and there's 2, 1 and 5. So it's 2 out of 36. Alma disagrees. She thinks that the probability of rolling a 1 or 5 is greater. Probability of rolling 1 or 5 equals. You should count any pair that you can see 1 or you can see 5, as shown in the outcomes listed. As you can see here, we have 20 out of 36. Alma is correct. Option B is the correct answer because Alma thinks that the probability of rolling a 1 or 5 is greater.
Sarah and Lana are playing a game where they roll a pair of fair six-sided dice and try to predict the outcomes. Sarah thinks that the probability of rolling a 1 and a 3 is greater than the probability of rolling a 1 or a 3. Lana disagrees. She thinks that the probability of rolling a 1 or a 3 is greater. So let's find out who's correct. Lana's probability will be rolling a 1 or a 3. Let's write down Sarah's probability first. Sarah's probability will be rolling a 1 and a 3. So we have to count how many times 1 and 3 has been rolled together from the shown outcomes. 1, 2. They've been rolled together 2 times. So 2 over the total number of rolled dice, which equals to 36. Now let's write down Lana's probability. Lana's probability is rolling a 1 or a 3, which equals to, we have to count how many times a 1 and 3 has been rolled, together or not together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 times. So 20 over 36. As we can see here, the probability of rolling a 1 or a 3 is greater than the probability of rolling a 1 and a 3. So Lana is correct. Thank you.
What is the probability of rolling a 6 at least once in 2 rolls of a standard 6-sided dice? Each roll has 6 possible outcomes, so the possible outcomes in 2 rolls is 6 by 6, which is 36. The rule of probability is probability of an event happening equals to number of ways it can happen over total number of outcomes. Let's count the number of outcomes with at least a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The probability of rolling a 6 at least is 11 over 36.
What is the probability of rolling a 4 at least once in 2 rolls of a standard 6-sided dice? Each roll has 6 possible outcomes. So the possible outcomes in 2 rolls is 6 by 6 equals 36. Probability of an event happen equals number of ways it happened over total number of outcomes. Let's count the number of outcomes with at least a 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The probability of rolling a 4 at least is 11 over 36.
The question says the tree diagram shows the composition of a box of used color markers in a classroom. There are 2 red markers, 4 green markers, and 6 blue markers. Let's write them down. So 2 red markers, 4 green markers, and 6 blue markers. 1/2 of the red markers have dried out. So half of the 2 red markers are dried. So one of the red markers are dried and the other one of the red marker is not dried. 25% of the green markers are dry. So 25% of the 4 green markers are dry, which is only 1 dried green marker, and the other 3 green markers are not dried. And 50% of the blue markers are dry. Half of the 6 blue markers are dried. So 3 of the blue markers are dried, and the other 3 of the blue markers are not dried. What is the approximate probability that a marker randomly selected from the box will be dried out? A. 0.063, B. 0.417, C. 0.333, D. 0.538. So they're asking us the probability of a marker randomly selected from the box will be dried out. So let's write it here. A marker randomly selected from the box will be dried out. So now, in order to find the probability, we're going to do as a fraction. The bottom of the fraction will be the total number of the markers. So there are 2 red markers, 4 green markers, and 6 blue markers. In total, there are 12 markers. And they are asking us for the markers that are dried out. So there are
1 tried red marker, 1 tried green marker, and 3 tried blue markers. In total, there are 5 markers that are tried out. So this is the answer as a fraction. However, we want it as a decimal. So as a decimal, it will be 0.417. So the answer is B. The answer is B. Hope you understand. Thank you.
What is the probability of tossing 4 coins and getting exactly 2 heads? At first, we have to find the probability of exactly 2 heads. Let's find out how many of the total possibilities have 2 heads of the total of equally likely possibilities. The probability of exactly 2 heads. So we know there are 16 equally likely possibilities. How many of those have 2 heads? To save time, I've drawn all of the 16 equally likely possibilities, and how many of these involve 2 heads? Let's find out how many of those involve 2 heads. This one over here has 2 heads. This one over here has also 2 heads. This one over here has 2 heads. This one over here has 2 heads. This one over here has 2 heads. And this one over here has 2 heads. So if we count them, we have 1, 2, 3, 4, 5, and 6 of the possibilities have exactly 2 heads. So 6 of the 16 equally likely possibilities have 2 heads. The probability of getting exactly 2 heads equals 6 over 16. So we have a 3 over 8 chance of getting exactly 2 heads.